Okay, let's look at this situation where we've got a tennis ball. It's moving towards this wall with an initial velocity of 20 meters per second, hits the wall and then bounces from the wall with a final velocity of 15 meters per second. Let's assume that the time of collision, that very short time in which the ball is in contact with the wall, is, let's just say, 0.01 milliseconds. So, at this particular moment, I want to deal with the change in momentum of this ball. Let's look at the initial momentum. Initial momentum of this ball is this value times this value. What do I get? I think I get 0.40 Newton seconds to the right. This is the initial momentum of this ball. What's the final momentum? 0.3 0.30 Newton seconds to the left. How can I work out the change in momentum? Change in momentum. Very easy. I get the final momentum. I subtract the initial momentum. Remember, when change is mentioned, it is a subtraction. When resultant momentum is mentioned or net momentum is mentioned, it is directly addition. But here we've got to subtract first time because we are finding the change. And we have said we treat any kind of subtraction as a special case of addition. This way I want you to pay close attention to what I do here. What is the direction of the initial momentum? To the right. Now I've got to reverse its direction so that it points that way. Yeah, let's see. Final momentum is this way, 0.3, represented by that short arrow, plus the initial momentum. I've got to change its direction so that now it points, no longer points to the right, it must point to the left on account of this negative sign, so that that negative sign can be taken care of by this change in direction. And it's going to be very easy. So I'm going to start with this one here. I draw that. And then I bring the tail of this one to the head of this one here. So let me just draw that so that it does not. I have it like that. Where did I start from? I started from here. Where did I end? I ended up here. And this is it. And it becomes equal to the final momentum, which is 0.3 plus 0.4. You can use any kind of scale and you'll get 0.7 Newton seconds to the left in the direction of the final momentum. In the direction of the final momentum. Look at the final momentum here. To the left. The change in momentum, in this case, when they are in the same straight line, it is always in the direction of the final momentum. And when you are rearranging this equation here, always start with the final vector, the final momentum, in this case. And you can see you end up adding them. This confirms a situation where you have this. The summary which we always make here is this. If you have an object of mass m, a ball, moving towards the wall, hits the wall and bounces with the same magnitude of the velocity, then the change in momentum is always minus 2 mu. How does that 2 mu come about? It comes about because here we've got the final momentum and the initial momentum, they've got the same magnitude, mu in this case, in each case. And then when you add them, you find that they point in a direction which is opposite to the direction in which you are taking momentum to be positive, because anything to the right is positive. It follows that anything to the left is negative. So I'm going to look at one more example in the next video that pertains to change in momentum of a tennis ball, which is either being hit by a racket or it bounces off the wall. But in this case, it is going to bounce at an angle. It will not be in one straight line like this. So see you in the next video.